I'd like to welcome everyone to FLIR's webinar on our new industrial ultrasound imaging camera. Today's webinar will be presented by our Director of Sales for our critical infrastructure team, Ed Kahanik. Ed, it is all yours.
Jason, thank you very much. And good afternoon, everybody. Welcome to this webinar. I want to thank you for taking time out of your schedules. I know we're working in a new environment these days with regards to COVID-19. And at FLIR, we were hoping to put together a series of webinars that are both educational and useful in helping you understand your business better and how to get the most out of your technology. Today, we are going to be addressing the very new product, the Si124. That is FLIR's industrial ultrasound imaging camera. And the applications are for compressed air and partial discharge. So the agenda will be as follows. What is ultrasound? You know, ultrasound is different than infrared. We're used to infrared. We'll discuss the compressed air applications, the partial discharge applications. We'll go through the Si124 as well, and we'll do a summary with Q&A. So as Jason had mentioned, please add the Q&A to the chat function, and we'll answer those questions as we go along. I hope to accomplish this in 30 minutes. If I run a little long, I'm going to apologize ahead of time. Most people know FLIR. FLIR stands for Forward-Looking Infrared. Our name is our business. But what most people don't realize is that thermal only makes up roughly 60% of our business. The other 41% is made up by other sensors that we make to protect lives and livelihood. The Si124 fits neatly in the non-thermal section of our product portfolio. And I'm really proud to go through that today with you guys. But first, before we get to what the problems are that this can solve, I'd like to introduce you a little bit to what ultrasound is. Ultrasound technology uses high-frequency sound waves to pick up potential performance malfunctions in mechanical, electrical, and fluid systems that are ordinarily indiscernible. Airborne structure-borne ultrasound instruments receive high-frequency emissions produced by operating equipment, electrical emissions, and by leaks. These frequencies typically range from about 20 kilohertz to about 100 kilohertz and are beyond the range of human hearing. As humans, we tend to hear, as we are doing right now, between 1 and 5 kilohertz. If you look at this chart below with the scale, you can see that ultrasound the sound scale is broken up into 3 sections. There's infrasound, acoustic sound, right? We firmly are in the acoustic sound. We've always heard that dogs can hear at a higher frequency, and that is clearly defined by this chart where they can hear higher frequency, and that is starts to get into the ultrasound section. And that's firmly where the Si124 works. It works in both the acoustic and ultrasound spectrums. But why use ultrasound? I'm not certain how many are familiar with this chart. It's called the DIPFA chart. It's the early detection of potential failures. And the DIPFA stands for design, installation, and potential failure life cycle of a tool, instrument, or product. If you go through this chart, you'll see that I is when you install the product, and F is when the product fails. So as the product is being utilized, eventually through wear and tear, it starts to fail. One of the first things it does is it starts to sound a little different. Now, our ears may not pick that up, but if you use the correct device, like an ultrasound listening device, you can clearly pick up that sound. And what's important about that, that happens way before any other technology can discern if there is a pending problem. What's really interesting is thermography falls later in this chart. It goes from predictive maintenance to preventative maintenance, right? And in many cases, thermography, which is very simple and easy to use, is one of the last lines of defense. So when things go bad, they heat up. But prior to that, when things go bad, they start to make a sound. And this applies to a lot of the electrical equipment that you're running in your facilities, whether through partial discharge testing or corona, mechanical items like rotating equipment, belts, bearings, and conveyors, and gas leaks, compressed air, steam systems, natural gas. They all make a distinct sound that the SI124 can pick up. So now we're going to talk about compressed air leaks in manufacturing and electric generation plants. The U.S. Department of Energy estimates up to 30% of manufacturing facilities' electricity is consumed for compressed air. That's a lot of energy for just compressed air. An average of 1/3 of these systems, or 1/3 of the compressed air, is wasted due to leaks. And based on a manufacturing plant facility running a 200 horsepower compressor, roughly 6,800 hours a year, using 11 cents as a kilowatt per hour, your potential savings could be $38,532. That's almost twice the cost of what the SI124 is. So if your accountants would tell you, if you get a payback in 2 years, make the investment. Well, you're getting a payback in roughly a half a year or 1/4 of the time by utilizing this device strictly for air leaks. As we just identified, air leaks do cost money. There was a report done in Plant Services in 2006, 14 years ago. You can Google it, it's there, by Paul Studebaker. And what they discovered is, you can save a lot of money by utilizing ultrasound to discover air leaks. And this is the rough savings that you can achieve. A 1/4-inch air leak at around 8,500 hours a year at 8 cents a kilowatt hour is going to be around $11,427 based on 80 PSIG. If it's a little higher PSIG, you're around 13,867. So finding these air leaks is imperative for saving your organization money. You want to become more efficient. You want to be a better run operation. What you really want to do is look at your system and try and find out where there are additional cost savings can be had. But why does ultrasound pick up air? A pressurized leak will cause turbulence, which can then be located using ultrasound. When air leaks into air, finding it using any other method other than ultrasound can be difficult. With an advanced ultrasound system, it can be very easy. Background noise is effectively filtered out. Therefore, the FLIR Si124 camera can work in noisy conditions. What we hear with the Si124 picks up from air leak is different. So what we hear versus what the Si124 picks up is completely different. So we always get the question, can I use this in a noisy environment? Yes, you can. It's perfect for that. So where do you look for air leaks? Well, obviously, you can trace your entire system. The couplings, the hoses, the tubings, the fittings, the pipe joints. As you can see by this chart, almost every application or every tool or every hose or every clamp or every fitting is a potential for an air leak, especially the parts that get wear and tear and are used frequently. This is very important because these air leaks, if you have the right instrument, can be easy to find. So hold on a second. Thank you. So as you can see from this picture, the camera, the Si124, is one-handed. It's lightweight and well-balanced at 2.2 pounds. The battery can last 8 hours and fits in a bag that you sling over your shoulder, or you can place it in a backpack. You basically point and shoot and scan your entire system. So this individual is looking at his screen. We'll talk a little bit about the screen, but he's really looking for a heat map, an identifiable heat source on the camera, looking for localized ultrasound. And the reason why it works is because ultrasound emissions are directional. Ultrasound tends to be highly localized. You don't need a lot of training. It's actually easier than thermography. You are not worried about emissivity or reflectivity. You're just worried about whether or not you see a spot on the screen. And then what you need to determine is if it's a reflection or not. And we'll talk about that in a minute. It's so simple, this device doesn't even have an on-off button. Just plug it into the battery and it turns on. And like I had mentioned, you can get up to 8 hours. This is different than older ultrasound systems with a parabolic mic. There's advanced intelligence on this, that when the signal comes in and the device processes that signal, it can determine and identify where it's coming from and what's the cause. Here's an example of how easy it's to use, right? Right now, the LCD is a color display, but for contrast purposes, we do the background in black and white and use the color to highlight where the area of interest is coming from. So black and white image with color contrast to pinpoint the problems. You can save the images. Each image stores about 2 seconds worth of information for further reporting or further analysis. So at this joint right here, up about 15 to 20 feet away, we clearly see that the Si124 has identified an air leak. There's a good chance you could have walked under this many times and not even recognized this is where you could be losing air. Also, the Si124 has filters to fine-tune the ability to find the source of sound leaks. Be aware of reflections. If you see a problem, you may have to walk around with it. And if the problem starts to dance around the screen, you know you've seen a reflection. But as you walk around it, if the heat map, if the red spot sticks on the target, then you know this is where you have an air leak. It's not unlike infrared, where in the past, if you had solar reflection, you had to walk 360 around the utility pole to see if the sun was reflecting on it. It's somewhat similar in that fashion. So for example, here's another pipe joint where there's air leaking. You might not have known about it. This is a good example of finding these problems quickly and easily and not needing a lot of training to do this. Here's a leak on a shutoff valve. The red color on the heat map as well indicates where the air is leaking from. On this example, we have a refrigerant line, and we can see the air, again, due to the heat map, is leaking. If you notice that there's a blue color over here in the upper right of the image, that is quite possibly a reflection. So the sound could be bouncing off this, the refrigerant or the frozen area and back into the camera. But as you walk around this, you're now going to find that that's where the air could be coming from. Again, I want to emphasize, this is very simple and easy to use. One of the nice things about the Si124 is that there's onboard analysis tools that give you the ability to tell you how much air you're missing or leaking. And then it has inputs for kilowatt hours, so it can do the calculation in real time for you to indicate how much that air leak is costing you to run your compressor continuously. There's also a nice feature built into this, where if you save this picture, it will now create a sound clip of 2 seconds that you can upload to a free cloud service that will allow you to create a report. And here's an example of what that report can look like. In the lower right-hand corner right here, we're saying that this leak is 30 cubic feet per minute. And based on the kilowatt hours utilized at your plant, you're going to save over $450 per year by fixing this leak. So what I'm going to do now is talk about partial discharge. And for years, customers have asked us, can thermal cameras see corona? And the answer is no. Corona happens in the ultraviolet spectrum of the electromagnetic spectrum, and infrared is several spectrums over to the right on the chart. But partial discharge or corona makes an audible sound that ultrasound devices can pick up. And partial discharge occurs anywhere there's a junction between two electrical components. Examples are within solid insulation across the surface of insulation materials with gas bubbles and liquid insulation, and around an electrode surrounded in gas. So that's what a partial discharge is. And when things go bad, there's a potential for an explosion and failure. A lot of times partial discharge happens well before there's a thermal image. So why is partial discharge bad? Well, a couple of things. It creates a loss of power. Electricity is lost to air during ionization. Electromagnetic interference that affects radio and television broadcasts. So when you drive by a utility pole and you happen to have the AM radio on and you hear that static, that's potential partial discharge. Sometimes when you're in a substation, you can hear these audible noises. But the two things that really cause problems is the production of ozone that is especially destructive to housing materials of polymeric insulators, and creation of mild concentrations of sulfuric acid that is also harmful to polymeric insulators, as well as to metallic conductors and other line components. Basically, when you see partial discharge by using the ultrasound device, more often than not, there is not going to be a thermal signature. This happens before thermal, just like with air leaks and other problems. Infrared is a complementary technology for some of these. In this case, I would use the ultrasound device on insulators and then come back up with the thermal camera, see if there's any temperature differentials there, because that would indicate whether or not the problem has progressed further. So what are the classifications of partial discharge? There's corona, which is the ionization of fluid or air surrounding a conductor. There's tracking, surface tracking over contaminated insulation, and arcing, electrical breakdown of gases producing a plasma discharge. How does this work? Well, basically, in the same fashion as you used the Si124, looking at for air leaks, you use it the same way. You look at it, your insulators. And when you see, again, the heat map on the insulator, for this to work, you need a second bit more of an analysis, meaning you store that image, and storing the image is simply just touching the screen of the device. You connect it. When you're done, you take all your images, you go back to your office and use the hotspot, and this uploads all the information to the cloud service, and the cloud service then does the analysis for you. And the cloud service does one of three analyses based on the profile of the wavelength created by the ultrasound. One is it discharge into air, which is okay. One is it discharge to components, which is okay. Or three, one is discharge internally or discharge on the surface. If it's discharge on the surface or internally, you will see right here this orange box that indicates potential issues. So here, we're seeing now discharge on the surface or internal. According to the sound profile, the device says, okay, I think we have a problem. So the first thing that you should be doing is you take out a pair of binoculars and take a look at it, because sometimes dirt and debris can help you, can cause this partial discharge. So you want to eliminate whether or not it's dirty. If it's not dirty, then more than likely there is a discharge happening with inside the insulator. It's causing it to break down, and eventually it will cause a failure. Another easy way to do this is, if you want to do this out in the field, use your smartphone like I'm doing right now. I created a local hotspot. I tied my computer in, so now I'm running off my smartphone's Wi-Fi. Well, you can tie your Si124 to the hotspot on your smartphone. You take the image, and the image will automatically be uploaded to the cloud. Then once it's in the cloud, you give it a minute or two, you go on your web browser to the location where you're storing it, and there it's going to give you its diagnosis. So you could go check out a couple insulators. If any of the insulators have a problem, save the image. Once you have the image saved, go continue on your route. When you're done, then you can review it while you're there, and then you'll get this diagnosis. In simple situations like this, we have, the fix was simple enough. We have a discharge inside the component. It's obvious we're close to it. We don't need binoculars. We can see that it was clean, and all they had to do was tighten it up using a hot air blower. Here's an example of another faulty insulator. We can see where there is the heat map is located on the lower bottom portion of this insulator. The diagnosis was discharge on surface or inside the component. You pull out your binoculars like I had mentioned before. If there's no dirt or debris or bird poop, then more than likely there's an issue. I would then always have it, if I have the camera, my infrared camera, I take a look at this. Now, one of the things with an insulator is you almost want to look at it late in the early evening after the sun's gone down, because the temperature differentials will be really small compared to a loose connection. So what you'd want to do is take a look at this when everything is much cooler and there's no solar loading. And then if you see a couple degree temperature rise, now you really know you've got an issue, because you're going to get an ultrasound before infrared shows up. But then if infrared shows up, now you've got a situation that could be catastrophic in a very near term. Here's an example of a discharge between components. So we've got the insulator, the bushing, the connection. So it's discharging between the components while it's making a ultrasound, that the camera is picking up. The advanced intelligence is picking up that this is not a problem. That's why it's shading it in the color green. Corona likes to happen around very sharp and pointy edges and ends. Here we have one, high voltage. You can even see the corona rings around this bushing and insulator. Up here where the heat map is, the software has determined that that is being discharged into air. This indicates a normal operation. So that is the bit on both compressed air and partial discharge. What we're going to talk a little bit right now is, what is the Si124? And S stands for sound, I stands for imager, and 124 means it's 124 Lowe's noise MEMS microphone for real-time sound visualization. I mentioned it was lightweight and portable, only 2.2 pounds, and can be operated with one hand. You can go a full 8 hours on the battery. Operating ranges from close to mid distances, and you do have inputs for the distances for, up to 50 feet or up to 328 feet. I mentioned the built-in Wi-Fi for connecting to the cloud for further AI-powered analysis. It has onboard instant analysis for air leakage. While it stores a black and white image, it uses the screen, the 5-inch color screen for the heat map. And like a thermal camera, it pretty much works in any environment that you want to work in. MSRP is slightly under $20,000. I'm not going to go through the specs because there's a lot of them here. We are recording this, even though we'll have to do some fine editing to eliminate that gap of time where I was not present. But I will we'll probably run another one where I'll just re-record this and we'll post it. But here are the specifications that you can review at your leisure after the fact. I can't mention this enough. It is very simple and easy to use. It is unlike other types of past ultrasound devices where there was extensive training on processing and understanding what you're listening to. This device is different. This is listening to those sounds as well, but the advanced intelligence is giving the ability to recognize what those sounds mean and show them to you as areas of concern. So in summary, I just mentioned it was easy to use. It converts ultrasound to an image. So if our eyes can see it, people believe with their eyes, not with their ears. I've been saying that about infrared for 20 years. I will say it the same for this device. A picture is worth 1,000 words. It was never so true here. Very simple, easy to use. And with one hand, you can safely walk around your environment and not be so, worried about if you slip or fall. What do you do with your 2 hands that you're holding this device? You just need it for one. And finally, it's a very quick payback. Air leaks can pay back in a very short period of time. And utility problems, one problem can pay for itself. Thank you.